Let's work a problem of a perfectly elastic collision. So we have a marble that initially is approaching a second marble, so marble 1 has mass 1 of 50 grams or equivalent, or in kilograms this would be 0.50 kilograms, and this marble is moving at 2 meters per second. We arbitrarily represent the marble moving to the right, so velocity of marble 1 is 2.0 meters second, and this marble strikes a second one with mass 20 grams, or in kilograms 0.020 kilograms, which initially is at rest. So velocity of marble 2 at the initial time is 0. So these are initial velocities. We can add an I index to indicate these are velocities at the initial time. At the final time, after these two marbles collide, they will be moving as separate objects. So probably marble 2 will be moving to the right with some final velocity that is unknown, and marble 1 will be moving probably to the left with some final velocity that is for the moment unknown. And the question then is to find the final velocities for marble 1 and marble 2 after the collision. So let's write then our equations from the previous slide. So remember that for perfectly elastic collisions, the following two equations are valid. Okay, so substituting values, for, let's say, first marble 1, we have M1, which is 0.050 minus M2 divided so we have mass 1 in kilograms minus mass 2 in kilograms 2 minus mass 2 in kilograms as well, and we divide by the sum of mass 1 and mass 2 and multiply by the initial velocity of object 1. After doing the math, you get 0.86 meters second. Since this is a positive velocity, that means object 1 is still moving to the right. Because initially we set positive velocities as velocities pointing to the right. For Marvel 2, we substitute the numbers from the corresponding formula. So velocity 2, the final time, is 2 times mass 1 divided by the sum of mass 1 and mass 2 multiplied by the initial velocity of object 1, and we get 2.9 meters second. So this is the final velocity for object 2. Since it's positive as well, that means object 2 is moving to the right. And then we have the solution to our problem, and we're done. Now, note how, since object 2 is moving faster than object 1, what this situation represents is that object 1 slows down. It went from 2 meters per second in the initial time, and now it's moving with 0.86 meters per second to the right, and object 2 is moving faster to the right, so it's moving away from object 1 at 2.9 meters per second. So object 2 is moving away from object 1 that has slowed down. And that's the solution for this problem.